This is the fourth and final video where we're looking at the titration of a weak acid with a strong base. In the previous videos, we looked at the pH before any base was added. We looked at the pH after base was added, but before the equivalence point. The third video, we looked at the pH at the equivalence point. And now we're going to look at the pH after the equivalence point. And so like the second and third videos, this is going to be a two-step calculation. First is going to be a stoichiometry calculation, where I look at the reaction of the strong base plus the weak acid. And then the second step is to use what's left over after the first reaction to determine the pH. And so I've got the chemical reaction that we've been looking at of my strong base plus the weak acid. And the initial moles of acid that we calculated in previous videos doesn't change. And so to finish off my BCA table, I need to calculate the moles of hydroxide. So to do that, I'm going to take the concentration times the volume. Convert the 240 milliliters to liters. And I get 0.120 moles. So I'll put that into my table. The conjugate base is initially 0. So in this case, the weak acid is now my limiting reagent. Products will be positive. So now I'm left with no weak acid. I have some strong base left over and some weak base. So what I have in solution at this point is no weak acid, and I have strong base and weak base. Anytime I have strong base left over, it overwhelms any effect that the weak base would have. And so I can ignore the effect of the weak base on the pH and just focus on the leftover strong base. So this is my moles of hydroxide. And so in order to get the pH, first I need to convert that into a concentration. So the concentration of my hydroxide ion is going to be the moles over the liters. For the volume, I need to be careful. So I started with 100 milliliters of weak acid, and I added 240 milliliters of strong base. So I need to add these together to get the total volume of the solution at this point. And converting that to liters. And so my concentration of hydroxide is 0.118. So I can get the POH by taking the negative log of that. And so my POH comes out to be 0.929. And then I know that pH plus POH is equal to 14. So the pH is 14 minus the POH. And so I get a pH of 13.071.